Hello everyone, my name is Jiaxin and my metric number is 8220733. I am a statistics student at University Kebangan, Malaysia. Today my presentation topic is applications of diverse and integrals in driving and motion. This topic is about how calculus can be used in real life. In this presentation, I will explain how derivatives are used to find velocity and acceleration and how integrals are used to find the total distance. I choose driving and motion because it is easy to understand and closely related to our daily life. It also shows how mathematics can help us explain real-world situations. First, I would like to briefly explain what calculus is. Calculus is a part of mathematics that studies change and total amount. It is useful when something changes continuously over time. There are two main parts of calculus: derivatives and integrals. A derivative is used to find how fast something changes. For example, when a car is moving, its position changes with time. The rate of change of position is called velocity. An integral is used to find a total amount. For example, if we know the velocity of a car over a period of time, we can use integration and to find the total distance traveled. So, in simple words, derivatives help us understand the change, while integrals help us find the total amount over a time interval. Calculus is important in many fields, such as physics, energy, economic, transportation, and data analysis.
小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉吗？我会永远护着我的真爱粉。小伙伴们，最近好多人让我退网，你们真的乐意吗？我不相信你们是那种人，会有人支持我的。如果你是路人，或者第一次刷到我的视频，你愿意留下来当我的真爱粉。
The objective of this presentation are simple. First, I want to explain the basic meaning of derivatives and integrals. Second, I will show how derivatives can be used to find the velocity and the acceleration. Third, I will show how integrals can be used to calculate total distance from a velocity function. Finally, I will connect these calculus ideas to a real-life driving situation. Through this presentation, I hope to show that calculus is not only a theory. It is also a useful tool for solving real-world problems. Now let us look at derivatives in daily life. A derivative tells us how fast something changes. Many things in real life are always changing. For example, the speed of car changes, the populations of a country changes, and the cost of production may also change. Because of this, derivatives have many practical uses. In driving, derivatives can describe speed and acceleration. In business, they can help find maximum profit or minimum cost. In biology, they can describe population growth. In energy, they can help study slopes and structures. In this presentation, I will focus on driving and motion, where when a car moves, its position changes with time. If we want to know how fast the car is moving at a certain moment, we need to find the rate of change of position. This is the main idea of derivative. So derivatives help us move from position to velocity and acceleration. Now let us discuss velocity and acceleration. Suppose st represents the position of a car at time t. Here t means time, and st tells us the position of distance of the car from the starting point. Velocity is the rate of change of position with respect to time. In calculus, velocity is the derivative of the position function. V of t equals s prime of t. This formula means that if we differentiate st, we get the velocity function vt. Velocity tells us how fast the car's position is changing. If the velocity is high, the car is moving fast. If the velocity is zero, the car is not moving at the moment. Acceleration is the rate of change of velocity with respect to time. In calculus, acceleration is the derivative of velocity. A of equals v prime of t. Since velocity is the derivative of position, acceleration can also be written as the second derivative of position. A of equals v prime of t equals double prime of t. This means acceleration tells us how quickly the velocity changes. In real driving, acceleration happens when the driver presses the accelerator. Direction happens when the driver presses the brake. Both can be explained using derivatives. Now let us look at a simple example. Suppose the position of a car is given by this function. S of equals to t squared plus 3t. Here st is the position of the car and t is time in seconds. To find the velocity, we differentiate the position function. The derivative of 2t squared is 4t, and the derivative of 3t is 3. So the velocity function is v of t equals s prime of t equals 4t plus 3. This means the velocity of the car at any time t is 4t plus 3. Now we find the velocity when t equals 5 seconds. We substitute t equals 5 into the velocity function. V of 5 equals 4 times 5 plus 3. V of 5 equals 20 plus 3. V of 5 equals 23. Therefore, the velocity of the car at 5 seconds is 23 units per second. This example shows that derivatives are useful. The original function gives the position, but after differentiation, we can find the velocity at a specific time. This is similar to looking at the speedometer while driving. It shows the speed at that exact moment. Next, let us discuss integrals in daily life. An integral is used to find a total amount, while derivatives focus on change at one moment. Integrals focus on the total amount over a period of time. Integrals have many real-life uses. They can be used to find the total distance, area, volume, total cost, and probability. In this presentation, I focus on one important use, finding total distance from velocity. When a car moves, its velocity may change over time. If we know the velocity function, we can use integration to find how far the car travels during a time interval. The basic idea is that distance can be found by adding many small moments together. Integration is the mathematical method for adding these small parts. This is why the area under a velocity time graph represents distance. Now let us continue with the velocity function from the previous example. We already found that the velocity function is v of t equals 4t plus 3. Now suppose we want to find the total distance traveled by the car from t equals 0 seconds to t equals 5 seconds. To find this, we calculate the definite integral of the velocity function from 0 to 5. The formula is distance equals the integral of from 0 to 5 of 4t plus 3 dt. Now we integrate the function. The integral of 4t is 2t squared and the integral of 3 is 3t. So we get distance equals bracket 2t squared plus 3t from 0 to 5. Next, we substitute the upper limit and the lower limit. For the upper limit, t equals 5. 2 times 5 squared plus 3 times 5, 2 times 25 plus 15 equals 50 plus 15 equals 65. For the lower limit, t equals 0. 2 times 0 squared plus 3 times 0 equals 0. Therefore, distance equals 65 minus 0 or equals 65. So the car travels 65 units in the first 5 seconds. This example shows how integrals can be used to find the total distance from velocity. In a velocity time graph, the area under the graph from t equals 0 to t equals 5 represents the total distance traveled. This is an important idea in definite integrals. In conclusion, derivatives and integrals are two important parts of calculus. Derivatives help us understand change at a specific moment. In this presentation, we saw that the derivative of position gives velocity and the derivative of velocity gives Acceleration integrals help us find total accumulated quantities. We also saw that the integral of velocity over a time integral gives the total distance traveled. Through the example of driving and motion, we can see that calculus is not only a theoretical subject. It is also related to real life. It helps us describe motion, measure change, and calculate total quantities more accurately. Therefore, calculus is useful in many fields, such as physics, energy, transportation, economics, and data analysis. Thank you for listening.